All right. Welcome, everyone. If you're seeing this, thank you for joining. Was able to give a version of this presentation in person to a group of folks in early June 2023 here in Johnson County, but wanted to make it available for anyone that maybe wasn't able to attend in person that day. So I guess without further ado, here is the Livestock Ultrasound presentation. My name is Micah Most. I am the Ag and Natural Resources Extension Educator in Johnson County, Wyoming, and put this little presentation together to share some about our livestock ultrasound contest that takes place at the county fair. So we'll be talking about what ultrasound is and how it works. And maybe get my slides to go. There we go. How it works. And we'll talk about some of the anatomy that it describes, looking inside the animal at some of those cuts of meat. And then finally, we'll get into the meat science side of things a little bit and talking about its actual application to livestock and the livestock industry. So what is an ultrasound? I had some really great responses from the participants yesterday at the in-person event, but I want to just take a minute. We'll sit here and think in our own words, what is an ultrasound, or what is our idea coming into this presentation of what an ultrasound is? A few things that came up yesterday was a picture inside the animal that lets us see what's going on in there. And someone else described being able to look at the size of the muscles. So those were some great responses. And I'm sure that whatever you mentioned in your head was right on track. So we're going to get into it a little bit here. What does it take to do an ultrasound? So if you are in Johnson County in 4-H and you participated in the carcass contest, you know that it takes the ultrasound console, which is this piece right here that looks kind of like a laptop, and a transducer, which is this thing on the end of the cord. These transducers, or you might hear me call them probes sometimes. Transducers or probes come in different shapes and sizes for different purposes. So you have to have this piece of equipment to actually conduct the ultrasound. You need to have some kind of contact element. So for the livestock side of things, it's pretty typically vegetable oil. If you watch a lot of medical shows on TV, or maybe if there's some parents out there, you might be familiar with the ultrasound jelly that you might see in a doctor's office, but some kind of element that helps transmit those sound waves from the probe, from the transducer, to the surface that's being evaluated. And then last of all, you have to have an animal, right? You have to have your livestock project in order to make all of this worth it. So it's kind of complicated how the ultrasound console and probe work together to capture some images of the inside of an animal. It's really amazing when you think about it. But the main way it works, or the way it works, is through sound waves. So that transducer, or that probe, sends out pulses of sound that we can't hear. We'll talk about that a little bit more later. And then it also measures or picks up how those sound waves are reflected or bounced back, how they move back towards it. So it sends out those sound waves into whatever surface is being evaluated and then measures what comes back towards it. There are a couple different ways that sound waves can be returned or not returned to the probe. So looking at this graphic here, there's 4 listed: absorption, reflection, scattering, and refraction. So with absorption, those sound waves go out, they hit something soft, and there's nothing returned. So there's no energy being transmitted back towards the probe, being received by the probe. With reflection, it works just like it would if you're looking at your face in a mirror, and it hits something hard and goes straight back to the probe. With scattering, maybe hits a smaller item or moves through a surface, and so those waves are scattered in many different directions. And finally, we have refraction, and that's where that wave is bent or sent into a different direction. So we can see here, it's moved from the probe out until we hit this object, this surface, and then it comes out at a little bit different angle. So this is pretty basic, pretty generalized information, but this is how that ultrasound console and probe work together to use sound waves to allow visualization of tissues inside the body. And I wanted to show this one because I thought it was pretty interesting. We see here in this kind of middle region, the audible range for humans. So all the way along this bottom axis of this chart are the frequencies, which is the number of waves in a certain amount of time, some physics that we're not going to get into today. So here's human hearing. Then we jump up here, fish finders fall into this range. Dolphins and their sense of hearing is here. Bats are even just a little bit higher. Bats don't have any overlap with the human range, so we don't hear their little squeaks and sounds as they're finding insects. But way up here, we have ultrasonic medical instruments. And so they are well above the range of hearing of dolphins and bats. And so we don't actually hear the sounds that are being emitted by the probe, being received by the probe to capture that image, but they are way up in the 1 megahertz region of that sound frequency. And so as those waves are being transmitted and then received back by the probe, maybe if you've seen an ultrasound image before in the past, you think it looks like a staticky TV. Some of you are probably too young to ever know what a staticky TV looks like or why it would be that way. But if you're familiar with that, it's kind of hard to tell, right? There's black and white. So in an ultrasound, solid or dense spaces bounce back those sound waves, and those are received by the probe, by the transducer, and those show up as white on the ultrasound image. And those soft or fluid filled spaces or tissues do not bounce back sound. And so they show up as black spaces in the image. And with that in mind, it becomes a little bit more easy to decipher what's going on in some of these ultrasound images. So we're going to practice with a few examples here. So here's a picture. And I'm just going to ask a question here. How many fluid-filled spaces do you count in this picture? So remembering, fluid-filled spaces don't bounce back any sound, so they show up as black. How many black fluid-filled spaces do you count? I see 4. So we'll go ahead and trace those out. There's a really big one right there. And there's kind of a smashed one right here. There's a really little one right here. And then kind of a medium-sized one right here. So I count 4. 1, 2, 3, 4 fluid-filled spaces. And if you have horses at home, or you're familiar with taking your mares to the vet to get them bred, you might recognize this photo. This, you can kind of see a circular structure that is outside all 4 of those fluid-filled spaces. This is an ovary of a mare, and each one of these spaces is a follicle developing on her ovary. So eventually one of those will rupture, which will cause ovulation. And you can see the little oocytes that are developing here. So one of these could potentially become a baby horse someday. So there's that example. We got another one here. Oh, before we move on, one of the really cool things about ultrasound is it's all to scale. And so you can use this image and a tracer tool to measure distances on there. So if you've taken a mare to the vet to have her bred, the vet is always measuring and checking to see how big these follicles are to know how close she is to ovulating, so she knows what time to breed that mare. And that comes in later with meat evaluation stuff too. We'll get into that later. Next example, so we see the angle is coming in towards the side right here. This structure is actually a heart. It's kind of laid over on its side. So it's looking a little bit different than we're used to seeing in an anatomical heart, and it's a cross section. And you can see over here in the ultrasound, that probe is positioned at the top and it directs down to the bottom. So not only I think is this a really cool illustration, but I think it helps us understand that ultrasounds are two-dimensional cross sections. So this top part of the ultrasound corresponds to the top part of that structure of that heart. And we see this open space right here is the right ventricle. So this is the part of the heart that receives blood coming in from the rest of the body. And you can see this dark space. Remember, dark, it means fluid filled. And in this case, that fluid is blood. This blood filled structure is the ventricle, the right ventricle, RV. And then we see the left ventricle right here is this big open space. We can see some of the little valves of the heart right here. So as blood is coming back to the heart from the lungs, it enters the left ventricle and then enters up into the left atrium. And from there, it goes to the aorta and out to the rest of the body. So this is a little cross section of the aorta right here, sitting right in there. So two-dimensional, it's flat. Even though we're looking at three-dimensional objects, our ultrasound is in two dimensions. It only has width and it has height, but it doesn't have that depth that we know does exist. So that's what makes it a little bit tricky if you're actually conducting the ultrasound, to find just the right place to place the probe and get the image that you want. And I believe there's one more example here. This one might be familiar to many. You can see some dark spaces that are fluid filled. You can see some white spaces that are indicative of some hard structures or hard tissues. And all of you are shaking your head at home, nodding along, that this is a human baby ultrasound. So you can see, just like positioned in this illustration, you can see the head, you can see the nose, you can see the spine. So you can see all of that bone tissue that's developing along the baby's back, as well as the umbilical cord and the arm right there. So this one is maybe the most common use of ultrasound that you might be familiar with if you're not familiar with the livestock application. And it was pointed out to me yesterday by a very attentive 4-H'er that baby ultrasounds are now coming in 3D versions as well. So there is 3D ultrasound for some human ultrasound purposes, but we'll only be talking about two-dimensional ultrasounds today. So that makes a nice transition. How do we use this in livestock carcass evaluation? Well, it allows us to look for a couple different things. We're looking at muscle mass and degree of finish. So muscle mass is a word for size or amount. So the amount of muscle, and degree of finish means fat. So finish is fat. Degree of finish, how fat your animal is. And these are important because they contribute to the overall overall value of your animal. So for muscle mass, we specifically look at the longissimus dorsi muscle. Everybody say that together with me at home. Longissimus dorsi, right? So that's commonly referred to as the loin muscle. In cattle, it's called the ribeye. And in sheep, in pigs, and in goats, it's referred to as the loini. Those are some industry details, but longissimus dorsi is the muscle that's being evaluated. And not only is that muscle a major part of some of the high value cuts out of the carcass that we'll talk about later, but it's easy to get to because it's right there on your back. If you put your hands on both sides of your spine, you can feel you have kind of two muscles that run up and down this way. Animals have that too. So it's easy to get to that when they're standing in the chutes. It's kind of hard to make pigs stand still, especially when they're covered in vegetable oil. So it makes it a little bit easier since it's already on their back where we can get to it. And the other degree of finish, we're looking at two traits there. We're looking at back fat thickness. So how much fat sits between the skin and the top of the muscle, and then marbling, which is intramuscular fat. It's fat that's actually inside the muscle, deposited inside the muscle. We care about those traits because the more muscle we have, the more meat we will end up with at the end. And we care about fat because fat is flavor. Fat contributes to the quality of the final meat product. So now we're going to move into looking at some skeletons and muscles to evaluate the anatomy. I didn't want to freak anybody out, so I wanted to give you a little heads up. Here they come. And I did want to give this disclaimer that we'll look at a few different carcass examples, but related to this muscle specifically, there are only minor differences between the species. For the most part, the musculature, the layout of the muscles is very similar across all of our livestock animals. So here we have a diagram of, this is actually a bull, but we're looking at the cattle anatomy, and this is showing some skeletal anatomy, it's showing some digestive anatomy. We can see the lungs peeking out through the ribs there, but I mainly want us to focus on the muscle that we can see. Obviously, this is all covered up with muscle too. They've just removed some of that so we can see through down to the digestive tract. But the one we're focusing on right here is labeled in yellow, and it says longissimus thoracis and lumborum muscles. And so remember, we talked about longissimus dorsi. Thoracis just means this region, the central region of the longissimus dorsi. Lumborum is this region down here, a little bit lower. So it's the thoracic cavity and the lumbar, which are related to the sections of the spine that it sits closest to. But it's this long, narrow muscle. My friends that work in the meat science area sometimes affectionately call it the meat rope. But this is where it sits. It's kind of long and it's a cylinder. So it's kind of a tube that sits right in there by the spine. Here's a different view of it. This is on a sheep, but it's the same basic idea. We see the pelvis down here at the bottom. And the base of the skull would be right up here. So this sheep is facing away from us. And we see that longissimus dorsi muscle stretches all the way, basically from the back of the ear through the neck and all the way down towards the hips where it attaches to the spine. So this long tube-shaped muscle, again, sitting right on the spine, and there's one on the other side too. So there's two longissimus dorsi, two L dorsi muscles in our animals and in us too. And this is a beef carcass shown hanging on the rail. So to get you oriented, this would be the back leg stretching out where they've taken the back foot off. This would be the front leg here, and this would be where they've taken the head off. But it's a little bit harder to see. Longissimus dorsi, though, is marked right here, and it runs, again, all the way from the base of the ear in the cervical section, that neck section, all the way down past the thorax and into the lumbar area. So those are some medical words that you might learn if you're interested in animal science or in medicine. Add those to your vocabulary. And I really like this image because remember when we were looking first at that bowl, we saw how that was that long muscular tube. Well, here it's been cut into sections. And so we can see that even though that muscle is still there and it's situated around some other muscles that run through there. But when you cut that, when you take a cross section, it looks a little bit different. It looks like a different shape. So when it's a long cylinder too, but when we cut it, it becomes a circle. So, or more circular. And so I want you to focus mainly on this shape right here, because from here, we're going to start looking at some actual ultrasounds, and I think you'll be able to recognize that shape. So here we have a beef ribeye, and to get you oriented to the image a little bit here, this way, towards this edge would be towards the spine, and this way would be down towards the ribs. So you set that ultrasound up on the back of the animal with one end towards the spine and one sloping off down towards the ribs. And you can see the different regions of white, which is harder tissue or a transition of tissue or surfaces, and some dark spaces that are more fluid filled or softer tissue. So As we go down, remember, we sit that probe on the top, and it shows us the top of the picture is the top of the structures that we're looking at. So this first white line on the very top is that transition from the probe to the skin. So this is the outside layer of the skin. When we drop down one more, there's another white line right here. This one represents the bottom of the skin layer and the top of the fat layer. And then we drop down one more to this third white line that runs right in here. That is the bottom of the fat layer where that fat meets the muscle. And so when we're taking back fat thickness, we would measure the distance from the top of the fat to the bottom of the fat. And it's usually approximately, well, it'd be right over here, about 2/3 of the way down the side of the animal. And then we see this big dark space. So we can kind of trace that around, and we could go all the way around. And that shape should look kind of familiar to you, because that is the muscle that we were just looking at on this previous slide. This shape right here, keep that in your mind's eye, is this shape right here. And we know that there's quite a bit of water in muscle and our other soft tissues. So we know that this is that muscle. So we've got the fat thickness, and then we would trace all the way around here would give us the area of that ribeye. And then lastly, the other thing we measure with ultrasound is marbling. So the computer would put a random box on here and count the number of all those little white flecks. So those little white flecks are a little bit harder. There's a little bit less water in there, and those represent all of the marbling. So all of those flecks of fat that sit inside the muscle. They're not sitting outside the muscle like the back fat is up here. They're sitting inside the muscle, and that is the marbling. So it would put a number to the amount of snowiness, or how much white is showing up in a certain area for marbling. And now you can probably hear the mower going outside, but we're going to keep going. So this is obviously not an ultrasound. This is a photo, and we have a pork loin here. We see the back fat very clearly. You see that loin muscle sits right in there. It looks very round in this picture. And we can see there are some flecks of fat, maybe not as much as there was in that ribeye, but there is still some flecks of fat inside that pork loin, in that pork chop. Here's another example of a beef ribeye. And I didn't mention it when we were looking at that ultrasound earlier, but the really clear indicator that you want to look for, one of your landmarks, is this double row of white that represents the fat. We call it the railroad tracks. So if you can find the railroad tracks that go all the way across there, that double row of white, that's the fat thickness that you've got. And you can use that to make sure you, if you're conducting the ultrasound, are in the right place on the animal. And here we can see very clearly that outline all the way around of that ribeye and right where it sits in there. Here's a traced out version. If I were to do this again, if I were to do this in the first place, I guess, this B marker from the fat thickness here is actually indicating from the outside of the animal all the way down to the bottom of the fat. So this is not the actual fat thickness. The actual fat thickness would go from the top of the fat to the bottom of the fat, right in there. Again, we can see those railroad tracks that sit right under the skin surface, because we don't want to eat the skin. We don't want to include that in our measurements. And you can see they've nicely traced that ribeye all the way around, so we can see the area. We can see the white flecks throughout some of that marbling that's present in this image. And so the sheep folks don't feel too left out. We've got a loin eye here. That's your lamb chop sitting right in there. It's very, very clearly marked out and easy to see. The railroad tracks may be a little bit harder to see in this one, but we can see that back fat thickness right through there, and a certain degree of marbling throughout as well. So when carcasses are on the rails in a slaughterhouse, they're split at the 12th and 13th rib. And I should have mentioned that's where all of these ultrasound images are taken, are right there between the 12th and the 13th rib. 13th rib is the last rib. So you find the last rib and you count one back, That's where these ultrasounds are all collected. That way they're all the same, and they can be compared to each other. So in a slaughterhouse, that carcass is actually split open with a knife. And so we can see this is exactly what we look at in that ultrasound. We can see the back fat right here. You can see the area of the ribeye. This one it's turned up on its end from the ones we were looking at. And you can see that marbling throughout in there. And on the rail, these clear plastic grids are used to actually count the area, the actual area. So with an ultrasound, we're just estimating. We're using technology to give our best guess, but in a slaughterhouse, you can actually count that area. And so this tool, each one of these boxes is equivalent to 1/10 of an inch of square area. So you count all of the boxes, and then there's a couple of tips and tricks to get the ones around the edges that maybe you're only halfway full. I'm not going to go into those details today, but that's how in a packing plant carcasses are evaluated for ribeye area. Here's an example with a sheep carcass. It's upside down, hanging on the rail, but we see those two loin eyes sitting there right on either side of the spine. And here they're actually measuring loin depth, which is a different measure. It's commonly used in Australia for the sheep industry there, the lamb industry, but is also, there's a formula that is used that translates the loin depth into the loin eye area. And you can very easily add the back fat thickness onto that. So for the Johnson County carcass contest or ultrasound contest, Dr. Paisley comes up from Lingle and he uses his ultrasound machine to collect those images. And then there's computer aided measurements. So he doesn't have to sit there and actually trace around all of those ribeyes. He's got a program that will do that for him, that will give him the loin eye area, the back fat, and the marbling score. And so those are compiled with the live weight of the animal when you weigh your animal in at weigh day for the fair. And that is plugged into all of this complicated math. There's a formula that then assigns a USDA yield grade and USDA quality grade based on the size of the ribeye, the back fat, and the marbling, so that muscle mass and degree of finish, like we talked about earlier. And these are official formulas, official scores established by the USDA, the US Department of Agriculture, and they help regulate all of the standards that we use to compare our animals to and assign them their scores. So we're going to talk about scores now, or yield grade and quality grade. So why does it matter? Why does it matter how big our ribeye is or how much back fat there is on our animal? We've talked about it a little bit already, but it really contributes to value. So the ribeye area, loin eye area, is our high value cut. I mentioned that already. It is a high value cut because it's really tender. It's a muscle of support, so it helps keep the animal standing up, but it's not one that they're walking on all the time. Like your biceps or muscles in your legs, they get worked out way more than your back muscles do. We call those muscles of posture, and it's the exact same in your livestock projects. So they're not quite as tough, they're not as stringy, and because they are more enjoyable to eat, they're a higher value cut. And degree of finish, how many times have you heard me say that phrase already, is important to evaluate because you want there to be enough fat that it's a good eating experience, but you don't want it to be too fat, because if your animals get too fat, then that all gets trimmed off as waste product in the slaughterhouse. And feed is expensive, right? What we feed our animals costs a lot of money. So when your animal is ready to go, you don't want to be pouring a bunch of more feed into it when all of that's just going to go to waste too. So degree of finish and ribeye area, these contribute and factor into the USDA yield grade score that we're going to talk about here. And then marbling is what contributes to the quality grade score. So these are the official USDA standards, the Department of Agriculture standards, and we can see on this scale, it goes from a moderately abundant amount of marbling where there's quite a bit of white flecks, that intramuscular fat, all the way down to slight, where we have to really look hard to even find anything that we might be fat inside that ribeye steak right there. So we're going to get into some more detail about that. Yield grade is how much product is there. Quality grade is what is the consumer experience. So we'll talk about yield grade first. Our goal with yield grade is to maximize muscling and minimize waste. And this really asks, how much meat will I be able to sell from this animal? How much is there? Again, muscle mass. How much do we have? And that varies from animal to animal. A quick note here, we use hot carcass weight when calculating yield grade, and that hot carcass weight is the live weight, so what your animal weighs when you walk it across the scale at the fair, minus the head, the hide, and the viscera or the guts inside. Some of those organs are consumed by certain groups of people, especially outside the United States. Organ meats are a little more popular in some other cultures, but ultimately, we're not eating most of this, and so it's waste, and this is the actual weight that has the most value to us when thinking about final meat product. So for beef and lamb, these yield grades, instead of being A, B, C, D, F, are from 1 to 5. So they get a number. Yield grade 1 is the heaviest muscled and the leanest carcass. Yield grade 5 is the lightest muscled and is maybe a little bit over fat or a little bit wasty. So we see here in this image, we've got this one, this example is a yield grade 2. So they can come leaner than this, but looking between this yield grade 2 and this yield grade 5 example, there's quite a bit more red here, which is showing us there's more muscle, maybe a little bit less fat. There's a lot of fat around this yield grade 5, and especially as we start looking down the sides to the ribs, because these are a cross section again, between the 12th and 13th rib of that animal. So as we look down the side, this muscle right here is very small compared to this one over here on the yield grade 2. Pork grades, yield grades at least, are based on muscle score, which is how much muscle they have, from 1 to 3, and last rib back fat. It's a little bit more complicated system, and I'm not going to go into those details today, but pork grades are also assigned based on how much muscle they have. So that was yield grade. Now we're going to get into quality grade. Quality grade, the whole idea is to maximize the consumer experience and to ask ourselves, how pleasant will the eating experience be for this meat? I made us all hungry yesterday at the in-person presentation, looking at these different cuts. So we recognize that this one is that ribeye steak. So this is the beef example. This rack of lamb, we know that longissimus dorsi muscle runs the length this way, but when we cut off a single rib, we see that little lamb chop sits right in there, looking delicious. And then over here on the right, we have a pork chop, and you can pretty clearly see that loin muscle, that longissimus dorsi muscle sitting right inside that pork chop. So all of these look pretty appealing to me, and we want our consumers to have a great experience when they're eating our meat product that we're raising. For beef, these are dictated very, very stringently by the USDA. They do a really good job of making sure that there's consistency in quality. So in this table, we're looking at maturity across the top and degrees of marbling down the side. So to go into that a little bit more, the A and B class maturity for beef carcasses are the youngest. So these are your feedlot cattle. And as we go towards the right, C, D, and E are older animals. So these are probably our slaughter cows, slaughter bulls, and older animals. Looking down the side, the degrees of marbling, we have slightly abundant, which is quite a bit of marbling, all the way down to practically devoid, which means there is no marbling, there's no intramuscular fat here. So then we're looking at the actual quality grades. Prime, choice, select, and standard are the ones you're probably most familiar with, and those apply only to the A and B maturity classes of cattle. So they have to be in that 12 to 18 month old, probably 18-month old age group, or 18 to 24, maybe in class B, and have a lot of fat to be eligible for prime, which is the best quality grade that's given by the USDA. Out here in the older classes, we have commercial, utility, and then there's cutter, which is covered up here by this picture that I put on here. And canner is also a quality grade assigned to mature cattle. Most of these are going to ground beef, so you won't see these labels on a steak in the grocery store. And I don't think you would want to eat a steak from an old animal anyway. And this picture that I showed before corresponds to these degrees of marbling here. So again, we see moderately abundant, would sit just above slightly abundant right here. And then we can go all the way down to slight, which is here, and then we can get even less than slight at traces or practically devoid. So degrees of marbling and maturity in cattle contribute to those USDA quality grades: prime, choice, select, and standard. If you've heard of certified Angus beef, you maybe have heard that they have a requirement for USDA prime or high choice cattle. If your steers that you're selling, trying to market through the certified Angus beef program, do not make at least high choice, they are not eligible to be sold with this label. So it is a really important thing when it comes to marketing. If you have prime beef, if you have high choice beef, that is very desirable to the consumer. Lamb quality grades are very similar to the beef quality grades, where we have maturity. Again, the younger animals being more likely to grade prime, and then it's actually flank streaking. So it's not intramuscular fat, but it's some fat that sits just outside the flank or just inside the flank of lambs that is evaluated from abundant all the way down to practically devoid, with the more abundant flank streaking being more desirable and causing those animals to grade prime. So we've got prime, choice, good, utility, and cull on the sheep side of things. Very similar to the beef side, so I won't go into more detail. Pork quality grades, they only have two. They have acceptable or they have utility. And acceptable is the only one that you will find in grocery stores. Utility grade pork will go into processed products, into canned products. Think beans and weenies, bologna, those types of things, hot dogs. You're not going to find utility grade pork in fresh product in the grocery store. So it's quite a bit simpler and a little more straightforward. Real quick, I don't want any of our goat exhibitors to be feeling left out because we haven't talked about them very much today. For the most part, during the ultrasound contest, they're run through and treated pretty similarly to the sheep. And that's because the USDA actually does not have standards established for quality or yield grades for goats. So there's not a USDA prime cut of goat that is in existence. They don't give those definitions, but that doesn't mean that we can't still evaluate for these traits. We certainly can, and we should. And so looking at these two animals down here, it's pretty easy to tell which one you think is going to have a higher amount of saleable meat as a fraction of its body weight, or which one's going to have more muscle that will be able to feed more people at the end of the day. So that evaluation, live animal evaluation, is just as important, especially on the goat end. If you've really liked some of these things that we've talked about here today, I want you to know that there is opportunity for 4-H meats judging. And then once you get into high school, or if you are in high school, there is FFA meats judging as well. And if you really, really like all of this kind of stuff that we're talking about, we can even get into some collegiate meat judging if you'd like. You can see here, this is the University of Wyoming meats judging team in a cooler. They've got several beef carcasses hanging behind them, and some lamb carcasses in the very background. But I wanted to point out clear over here on this side right here, you can see this carcass was split between that 12th and 13th rib, and you see that ribeye steak sitting right inside there next to the spine and the ribs, which you can see running down this way. So even though we know that muscle sits in there and it runs this way, kind of like a long tube, that when we cut it off as a steak, it turns a little more circular in shape. And this is my shameless plug as a university employee. If you really like this stuff, you can study it and make it your career. And there's actually a meat science and food technology option under the animal science major at the University of Wyoming. So I think that if I wasn't working in extension, this is an area that I would really seriously consider. I think it's fascinating. It's really important, I think, for us to understand with our 4-H livestock projects. We know with our market animals that end product needs to be safe. It needs to be high quality. It needs to be enjoyable for the consumer. And so our meat scientists and our food technologists help us accomplish those goals and help keep us on track to provide those excellent Wyoming steaks, Wyoming lamb chops, Wyoming pork chops that we all enjoy so much. That's what I have so far for today's presentation or this little talk. Thank you so much for joining. I appreciate you listening and your patience. My contact information is listed right here. I know there's not a chance for you to answer or to ask questions and have them answered live at this point, but shoot me an email or give me a call at the extension office, and I would be happy to share more, answer any questions, put you in contact with some more 4-H meats judging opportunities. So that's what I've got for you. Thank you so much.